In this tutorial we're going to look at how to plot geo-temporal data with Datascape. That is data which has both a spatial and a time component, normally latitude and longitude and elapsed time. For the example we're going to use some GPS data that was collected using an iPhone application as one of our employees cycled home from work. This is the data that we're going to use. Originally it came from a GPX file uploaded from an iPhone. And here we've just got it converted to a CSV, comma separated variable format. And the key columns, as far as we're concerned here at the moment, are latitude and longitude and also time. But you'll also notice we've got things like altitude and speed and pace, and if we wanted to we could visualize that information as well. And in this set we've currently got around about 590 records that we're going to be playing with. We import the data into Datascape the standard way. Here's the Datascape import tool, and just select import spreadsheet. Browse to find the spreadsheet that we're after and click on open, and on the analyze tab here we've ticked that we've got headings row, and here we can see all the headings, all the columns. All we just need to do is just set these to float. We know they're all number values, and float is as good a default value as any. And we're automatically going to create our own ID against each of the individual records, which is usually a sensible thing to let Datascape do. Give it a description. We'll just call it GPS test. Click on stop on errors just in case there's any problems, and import the dataset. And there we are, we've imported the 590 rows of data, and just confirm it's there. Click on datasets, view, and there's our GPS test data. So here we are in Datascape. First thing we need to do is to create a workspace. So in this case we've got mapping data, so we're going to go to the template map panel. This defaults to map of the UK using OpenStreetMap. Click on the map, you see the map wobble slightly so we know if it's activated. Here's the panel options. We're going to go down and we're going to go to the image type and choose OpenStreetMap. And what we can then do is set the latitude and longitude and zoom in. So we're just going to zoom the map in a bit. It'll take a few seconds sometimes whilst the map updates. Just move the map down a bit, seeing as we know we're going to want to try and centre ourselves on Birmingham. And zoom in a bit more. And that should do us. So just close the map settings. And if we now just hit the spacebar, drop back into fly mode. So here's our map of Birmingham that we're going to be using to do the plot with. To bring the data into the system, what we need to do, press spacebar, go into edit mode, touch the map surface again, and you'll notice here we've got the option load data onto this panel. So I'm going to select that. Here's my list of all my data sets, and in fact the cycling data is here as one of the demo sets anyway, so we'll just choose that. And what I'm going to do this time, it was already offering us a time map, but what I'm going to do is going to create it from scratch. So I'm going to create new mapping. So what we now need to do is just go through each of the properties and assign them to the fields from the dataset. So the ID property will assign to the ID field. The X property is what is going to be longitude, so assign that. The Z property is going to be latitude. So we'll assign that. We'll set Y to just 0 at the moment, so we've got no offset. And always a good idea to keep things very simple first time you bring some data in. So we're just going to have sphere. And red. And a size of 1. And we'll call this test mapping. And save that, and continue, and the data comes in, and if we zoom down here, we'll see we've got a little snail trail of all the points, so we might maybe want to make those a little bit bigger. So just go back to edit mapping, and let's just make them 2, and reload that, and now we're beginning to see the trail. If we want to show the information in 3D, so we actually want to put time onto the vertical dimension, press spacebar, go back to the dataset, and into edit mapping. And what we want to do is we want to make this y value dependent on time. Now Datascape doesn't understand anything about time, it's just looking for some sort of a numeric value. If we go into the data, then we've got GPS time, and click on that, and click on the eye, we can actually see what the range of fields are. Now, Datascape doesn't understand anything about time at all, so what we need to do is find a way of converting these times into numbers and offset from the earliest time. So basically we've got the time since the employee left the office, so I've just copied the minimum value there. And if we go back to the Y field, go back to the database assist, then you'll notice there's a function here called timestamp diff, and that actually calculates the difference between two times, so we're going to make use of that. So I'm just going to type in timestamp diff, and what we then do is tell it what units we want to do. So we're going to do this in a resolution of minutes, so type in minute, and then we give it the initial time and then the variable that we're comparing to that initial time, which is GPS time, and click on OK. And now if we click our eye, then we should find what we've got here is actually a value that runs from 0 up to 46. So that's basically the 46 minutes he took to cycle home. So we might decide actually that's a bit coarse, we want something a little bit finer in resolution. So all we do is we change minute to second. And have another look at that. Okay, that's more like it. So we've now got about 3,000, or a range from 0 to 3,000 across 588 different values, which is basically the sampling time. So what we're now going to do is save that. Just close the preview down and reload it. And here we see our time map heading off into the sky. Not particularly useful, so what we really want to do is control this a bit more and bring it into some sort of a scale. So to bring it into scale, you notice we've already got a vertical bar that comes as part of the default template. What we want to do is use that to control time. So what we're going to do is go back to our data set and click on Map to Objects. And what we do here is basically just make sure that the vertical bar is mapped to the Y value. Looks like it already was, but just go through that again. Click on this, click on Map to Objects. It asks us to select the object we're mapping to, and click on OK. So we've got that vertical dimension now mapped to the vertical bar. So what we want to do is just bring make sure the range on the bar maps the range on the data. So if we go back to our data, check what the range was for the y-axis, so that goes up to a maximum value of about 3,000. So we can go into the scene, here's our vertical bar, and scroll down here. Now note the length here is actually the size of the bar, not the range of it. What we want to do is set the range. So here's the range, we're going to set that to a maximum of 3,000. And you'll notice the minute I've done that, it's actually shrunk the vertical height. So what we've now got is the ability to control the vertical height using the vertical bar. So for instance, if I click on F, then it flattens the data immediately and brings it back up. And also I can adjust the height with the mouse. So actually if I stretch the vertical bar, we can increase the amount of offset that we're getting as a result of using mapping time to height. Now whilst this view shows us the points above the map in time, it's quite hard to associate their positions with the map itself. We've got nothing that joins the two. So there's a couple of ways we can do that. The first way is just by using reference lines. So what I'm going to do is select the data set. There's an option here for select all items. So we've now selected all the items in the data set. We see they've changed colour. We've got the items selected panel comes up here. And all I do here is click on reference lines for the x-axis. And you see what we've done is actually automatically just drawn a line straight down onto the map, so we can actually see whereabouts it was he was cycling. And this begins to highlight things like we've got a gap in coverage here, which actually corresponds with when he went through Sutton Park and through the woods there. There is another way to achieve time on a stick, so we're just going to clear the selection. What we're going to do is actually create a sort of bar chart. So I'm going to click on the data set. To create a bar chart, the basic principle is we take the y offset just going to copy a version of that, and we divide it by 2. And then we go to size and we unlink size. So this means we can make the size in the X, Y and Z directions vary independently. And we're now going to make the size in the Y value equivalent to twice the value of the offset in the Y value, and that effectively gives us a bar chart. The only slight correction we need to make is because we've got slightly different scalings. This is scaled in units within the space, and this is scaled in units based on the vertical bar. And if you remember, the vertical bar was 100 high and its maximum value was 3000, so that means we've got a difference of 30 in the scaling. So what we need to do is just divide by 30 so as to make sure the two match. We'll try and find a way of doing that more automatically in a later version. So I'm just going to save that and reload, and you'll see that we've now got something beginning to approach a bar chart. It looks a bit odd because we're still using spheres, so what we'll do is we'll go back and we'll change the shape, and instead of using spheres we'll use cubes. And let's reload that. Okay, and that's looking a little bit more like a bar chart. If we want a bit of definition between individual samples, then all we need to do is just change the size in the X and the Z dimension, so we'll just reduce that down to 1 and save that. And there we've definitely got something now that's approaching quite a nice diagram showing the employee leaving the office, the time he's taking, the route he's taking. Also, the nice thing about displays like this, it means if you've got multiple vehicles you're tracking or something like that, you can use time on the stick to clearly show where those vehicles get to the same location at the same time. And we'll just have a look at the demo set to see an example of that. So I'm just going to open the demo set GPS tracking. And here you see we've actually got 3 different data sets. So first of all, the yellow data set is the one that we've just been playing with. So that's showing the guy cycling home. But then you'll notice we've also got 2 other data sets looking a bit like snakes, one here in red and one in pink. You'll notice here we've plotted them as we did the cycling data initially, just as spheres and not with any vertical lines in them. And here if we just look at the mapping of these, then again longitude, latitude, timestamp diff so as to give us the offset, and colour is pink, just close that, and likewise for the other one, same calculation, colour is red. Note actually that the origin, if you like, of time is different for these 2 vehicle tracks and the cycling track. The 2 vehicles have got the same origin because they start at the same time. The cycling was actually done on a completely different day, but because we're all measuring them against a particular offset, we can put them all onto the same map. And you can quite clearly see with this data here where you get to a point where the 2 vehicles are actually following the same route but with a slight difference in time. The pink one gets to a location first, then the red one joins them, and then the 2 vehicles are at the same location for quite a period of time before they then head off in their own separate ways. So hopefully that's just given you a very brief introduction to how we can use Datascape to plot spatial and temporal data, and you could apply this to anything, including things like Twitter data or scientific data, anything that's got both a time and space component. Thank you.